So let's take a look at a quick example here. I want to find, oh, there it is. I want to find the gradient and directional vector in the direction of v equals -1, -2, 2 at the point 326 of f of x, y, z equals the square root of x, y, z. Now, first thing I need to do is I really need to take a look at finding my unit vector. So use my unit vector. That is going to be the vector -1, -2, 2 divided by the square root of 1 plus 4 plus 4, which is obviously going to be 3. So this is going to be, I'm going to put that out front right now. This is simply going to be 1/3 times this original vector. So there's my unit vector. So let's go ahead and find the partials that I need. So the partial with respect to x is going to be, obviously I'm going to have a 1/2, and then I'm going to have x, y, z to the -1/2 times yz, because I'm taking the derivative with respect to x. So that's going to be yz over 2 times the square root of x, y, z. And I need to evaluate that at, where's my point? There it is, 3, 2, 6. So that's going to be 2 times 6 divided by 2 times the square root of 3 times 2 times 6. So obviously my 2's are going to cancel. And this is actually the square root of 36, which is 6. So this is 6 over 6. So this is just 1. Now notice this piece right here. This is going to be the square root of 36, which is 6 for every one of these partials. So I'm going to have 2 times 6 in every denominator, because clearly this partial with respect to y is going to be the exact same thing, only when I take the derivative of the inside, I'm going to get xz. So this is simply going to be xz over 2 times the square root of x, y, z evaluated at 326. So I know my denominator is going to be 2 times 6 every time, and x times z is 3 times 6. So it's going to cancel, and obviously this is just 3/2. And then my partial with respect to z is going to be the exact same thing, only I'm going to have xy in the numerator over 2 times the square root of x, y, z. Evaluate at 326, which I'm going to have x times y, which is 3 times 2. So I'm going to have 6 over 2 times 6. So this is going to be 1/2. That means my gradient vector, del f, is simply going to be 1 3/2, 1/2. So that makes it pretty easy now to actually find the directional derivative, because the directional derivative is going to be the gradient of f dot u, which is going to be 1 3/2, 1/2 dot, I forgot what u is. It's something divided by √3. Oh, there it is. -1, not √3 over it, it's just 3. -2 over 3 and 2 over 3. So this is going to be equal to -1/3 minus 1, because it's 3/2 times 2/3. So -1 plus 1/3. So I'm going to end up with simply, because 1/3 is going to cancel, simply -1. So the directional derivative in the direction of this original vector v, which is -1, -2, 2, is -1.